Hello, today is February 1st. I'm going to document that. And there were some questions over why we multiply through by fractions. I'm just going to mute you, Jordan. Okay, there are some questions on why we multiply through on fractions by this least common multiple and how we get there. So one question was, how did we know to multiply by 15? The idea is we're finding a number when we multiply each of the terms. Terms are what's being separated by addition or subtraction. And then this is a term on the right-hand side. The idea is we want to eliminate the fractions so we don't have to worry about those when we go to solve for x. And so we're looking for the least common multiple, or least common denominator, least common multiple of these. So I would start by multiplying the smallest numbers together first. So if we take 3 times 5, we get 15, which is the third number. So that means we can use 15 because you need to use a number that each of the numbers are a factor of or can multiply by something to get to. Okay, so if I multiply each of these terms by 15, so I've got parentheses times 15, parentheses times 15, parentheses times 15. Then I'm going to, you could multiply straight across if you wanted to. So I could say this is a negative 30 over 5x plus 30 over 15 equals 30 over 3. And then when I go to reduce them, I can see, oh, negative 30 divides by 5 evenly to make a negative 6x plus 30 divides by 15 to make 2 equals 30 divided by 3 evenly divides by 10. So notice how we eliminated all the fractions. If you can see that 5 divides into 15 up here, 5 divides into 15 3 times, then we also use the word 5 cancels into 15 and there's a 3 remaining. That's how we get 3 times a negative 2. That's how we arrive at the negative 6 down here. And then if we say 15 cancels exactly with the 15, we have a 2 remaining, which is what we have down here. And then if we can see that the 3 divides or cancels into the 15 and you have a 5 remaining, then you can say 2 times 5 is the 10. And that's what we have down at the below. I just want to check. Are you with me so far, Jordan? You'll have to unmute.
Yeah, I got it now.
It's okay.
Now that you've explained it, it makes a lot more sense to me.
Okay, we'll do a few more. So then once we're here, we're trying to solve for x. And so then again, everybody should have on their, you get one note sheet, 8.5 by 11, double-sided for the exam. And so I would definitely have page 110, the instructions, so that you kind of know what to go through first. We eliminated the fractions and we don't have any distributive property. So now I'm going to circle my letter. Step 2, I believe, is getting all of the x's to one side, or it's actually gathering like terms. Now, our goal is Mrs. Main always likes to keep the x terms on the left and the constants on the right. So all my x's are already on the left. So I'm just going to move this 2 to the right by subtracting 2. And so that 2 and a minus 2, those cancel on the left. So we have a negative 6x equals 10 minus 2 is 8. This is problem number 3. And then we're solving first x. And so we're going to undo this multiplication by dividing by a negative 6. And so this leaves us with x equals a negative 8/6. And that can reduce to a negative 4/3. So let's do another one where we're multiplying through by the fractions. So if we look at number 4, we have 1/2 x plus 1/4 equals 1/10. third x plus 5/4. I definitely want to eliminate these fractions because they're stressing me out. So I'm looking for the least common multiple that they all can divide into. So I know that 2 can divide into 4. 2 times 2 makes 4, but 3 cannot divide into 4. So I'm just kind of playing around. You can do this in Desmos if you want. So I'm going to say, what about 4 times 3? 4 times 3 is 12. Then I can also make 12 by 2 times 6 will make 12, right? So as long as I can use each of my denominators to make the big number 12, so I can use my 2 times the 6 to get to 12, I can use my 4 times the 3, and I can use my 3 times the 4. And so 12 is going to be my least common multiple that I'm going to multiply through by. So I'm just going to rewrite it, showing you how I'm going to multiply by the 12. So 12 is going to get multiplied by 1/2 x plus 12 is going to get multiplied by 1/4 equals 12 is going to get multiplied by 1/3 x plus 12 is going to get multiplied by 5/4. Now, like I said, if you can see that 2 cancels into 12 6 times, because that's what we showed up here, 2 times 6 is 12, you can do that. But I'm just going to multiply my fractions so through, because that will kind of show you how it simplifies. So 12 over 1/2, 12 times 1/2 is 12 over 2x plus 12 over 4 equals, because remember, it's just multiplying straight across. We're treating this 12 as like a 12 over 1, and we're multiplying fractions. So this is going to be 12 over 3x plus 12 times 5 is 60 over 4. And then you can use Desmos by all means. So 12 divided by 2 is 6x plus 12 divided by 4 is 3 equals 12 divided by 3 is 4x plus 60 divided by 4 is 15. Now we've eliminated all of our fractions, and now we're to the step of getting all of our x's to one side. So I'm going to subtract 4x to move my x's to the left. And remember, I have to subtract because it's positive here. So a positive and a negative add to 0. That's what I want. So I have 2x plus 3 on the left equals 15. Circling x, and then subtracting 3 to move my constants to the right is 2x equals 12. And then my last step should be to divide by the coefficient, the number that is multiplied by x. So I'm going to divide by 2, divide by 2. So that leaves me with x equals 6. And again, if you want to be able to check your answers, you can go into Desmos and replace x with 6 and type this whole thing in up here, number 4 at the top here, and the left side should equal the right side. So let me show you how I would check my work in Desmos. Forcing yourself to check your work in Desmos will help you become a stronger student for sure. And more confident in Desmos and confident in math. Let's go ahead and go there. So I'm going to say parentheses 1 divided by 2 parentheses 6 plus parentheses. I'm putting my fractions all in parentheses just so. So that equals 3.25. Then on the right-hand side, I'm gonna do the same thing. 1 divided by 3 parentheses times 6 plus 5 divided by 4 parentheses. So they should equal the same thing if 6 is really the answer, and they do. Any questions so far, Jordan?
Nope. I get
Okay. So I also wanted to do a little bit of review because there's going to be a quiz this week on solving equations. So that everybody's getting ready for their chapter, their first exam in Math 104. And so I think if we turn to page 2 point, let me get to the make sure I'm looking at this right. Okay. Let's do some practice with putting our answers in interval notation as well from the 2.4. So 2.4, doing some good basic ones here. It's so if we were to look at number 2, it says, this is 2.4, page 157. It says 5x is greater than or equal to a negative 115. So all my x's are on one side, all of my constants are on the other. I don't have any parentheses or fractions, so I'm actually at the very last step of solving equations. So I'm going to divide by 5 to solve for x. And because I'm dividing by positive, I don't have to worry about flipping my symbol at all. So it's x is greater than or equal to, and then a negative 115 divided by 5 in decimals or on a calculator is a negative 23. I believe 5, 2, 10, 15, 23. Okay, so they asked us to give the answer in an inequality, which we did, and then graph the solution. So when they say graph, they're saying graph on a number line. So we're going to graph the solution. So I'm gonna mark 0 just for myself, and then a negative 23 is going to be to the left on the number line of 0. You do not need to be too particular about where it's at. Because it's greater than or equal to, let's write that out. That symbol is greater than or equal to. So x is greater than or equal to negative 23. Because it's the equal to, when we put a circle on negative 23, we're going to color in the circle. And because it's great, x is going to be greater than or equal to a negative 23, it's going to be everything to the right. Okay. Now, it doesn't ask for this, but I think every time we can practice our interval notation, it's a good time to do that. So my interval notation, I lined it up right with my number line. Because I'm including, it's greater than or equal to my negative 23, I'm using a bracket around the 23. And my interval notation is always my minimum value that x can be, comma, my maximum value that x can be. So the minimum it can be is that what's on the left on your number line, which happens to be the negative 23. And I'm coloring in my circles. So that means I'm using a bracket, comma, the maximum that x can be is forever and ever this way, right? So it's a positive infinity. A positive or negative infinity, when you use them, always gets a parenthesis. So a reminder there. So let's do the same on number 6. Number 6 is a negative 7x greater than or equal to 35. And because we have no parentheses, no fractions, all my x's are to the left, all my constants are to the right, I just have to divide by negative 7 to solve for x. But, so let's write ourselves a note. Because we divided by a negative, we have to flip the sign. So the negative 7's cancel. So we get x is, I'm going to circle my sign because I'm going to flip it. It's a less than or equal to now. 35 divided by a negative 7 is a negative 5. If you are not sure about these divisions and what they come out to be, you need to have a calculator next to you or Desmos so that you can easily be making sure you're getting those calculations correct. So because we had divided by a negative, we have to flip our inequality to make it a negative, less than or equal to. So now I am going to do my number line. And I'd like you to think about using your inequalities to help guide you on your number line as well. So because my inequality up here on number 2, my inequality was kind of pointing to the right, that's where I'm doing all my shading. Then when on number 6, my inequality is kind of pointing to the left, that's where I'm going to be doing all my shading. So that means a negative 5 is my biggest, my maximum value. So that's going to be a negative 5, and it's to the left of 0. And I'm coloring it in because it's a less than or equal to. And so this also helps set up my interval notation because again, my interval notation is going to be a parenthesis because I go forever and ever and ever to the negative infinity. And my right boundary, my maximum is a negative 5. And because I'm shading it in, I'm using a bracket. Okay. Any questions so far, Jordan?
No.
Okay. Let's do one where we're involving some fractions again, because I know that that's where a lot of folks need help as well as these inequalities. So let's look at number 16. So number 16 has 1/2 minus m over 10 greater than a negative 1/5. So because I have fractions, I need to find that least common multiple. And so like I recommended, I always start by multiplying the smaller numbers together. So 2 times 5 equals 10. And that's awesome because that's our third number. So 10 is going to be my LCD that I'm going to multiply through by. Okay. So I'm going to multiply this by 10. I'm going to multiply this by 10. And I'm going to multiply this by 10. Make sure you're also writing that on your paper. Okay, so I'm going to multiply through. This becomes 10 over 2 minus 10m over 10 greater than a negative 10 over 5. Now, you do not need to show me this step if you're someone, a student that's like, oh, I already see that 2 cancels into 10 5 times. You can do that using the first step. But if not, just multiply through, and then you'll get 10 divided by 2 is 5 minus 10 divided by 10. That cancels and makes just m greater than a negative 10 divided by 5 is a negative 2. And because I'm solving for m, I'm going to circle that. So my m's are all on the left, just like I like them. So I'm going to get my constant to the right. Because it's a positive 5, I have to subtract 5. So a negative m is greater than, and then a negative 2 minus 5 is a negative 7. And then because it's a negative, I need to divide through by a negative 1 to make m positive. And like we did in number 6, because I'm dividing by a negative, I have to circle that because I have to flip my symbol. So m is less than a negative 7 divided by a negative 1 is a positive 7. So my number line is there's 0, 7 is a positive, so it's to the right. And my inequality is pointing to the left, so I'm going to be shading to the left. And I'm putting a circle at 7, and I'm going to leave it open because it's strictly less than. There's no equal to. Excuse me. Okay, and so that helps me with my interval notation because my maximum number, my 7 is my maximum on the right. So I'm going to put a 7, and it's an open circle, so it gets just an open parenthesis. And then on the left, I can go all the way to a negative infinity, and it gets an open parenthesis.